Hi, welcome back. Today we're going to continue our discussion with vectors on a curve. Today we're going to use the calculator though. So we're given this parametric equation and they've given us dx dt and dy dt. Now remember, this is my horizontal velocity and this is basically giving me my vertical velocity right here. And at time equals 2, they give me the position as 1, 4. We're going to make that 7, 4 to make it look a little bit nicer for us today. Now the very first question they're telling me is just like we did yesterday, we're looking for the acceleration vector. So when I find the acceleration vector, we should make it look like a vector, so you should include your little chevrons here. Taking the derivative of our velocity, we get 3t squared from our chain rule times the cosine of t cubed. And for the change in y, we're going to get negative 2t. Again, the 2t from the chain rule, and the negative because the derivative cosine is negative sine. So it's negative sine of t squared. So there's my acceleration vector. Now they want me to find the acceleration at t equals 2. So if I plug in all of those, this becomes just 12 cosine of 8, negative 2, negative 4, we'll make that negative 4 because 2 times 2, sine of 4. And let's use our calculator to go ahead and get that. So when I turn my calculator on, I'm going to go to calculate, and this is the Inspire. Okay, now a lot of you guys know different ways to work the Inspire, probably better than me, so it's okay, I'm just going to do it my way for now. Make sure you're in the right mode, radian. So to get the x coordinate for my acceleration, 12, I'm going to go cosine of 8, and I hit enter, and it gives me negative 1.746. And now I gotta get the y, so I just go negative 4 sine of 4, press enter, and I get 3.027. And I include my chevrons. I'm going to put my chevrons because this is a vector, and that's how we identify vectors in calculus right here. Now the next question says, what is the equation of our tangent line? Well, we know how to do tangent lines. Very simple to do. So when I want to write the equation of my tangent line, one thing I need is a point at t equals 0. Now we're already given that. We're given the vector 7, 4. Next we need the slope. Well, to get the slope we got to use our derivative. Well, that's dy dx. But remember, vectors are like parametrics. So when I'm looking for dy, I'm really looking for y prime of t, and dx is x prime of t. And we're actually given those, right? Because y prime of t, that's right here, is the cosine of t squared. And here we get the sine of t cubed. So I can just plug that in. That's just the cosine of 4 over the sine of 8. And I can just type that bad boy in my calculator here. I get the cosine of 4 and I'm going to divide that by the sine of 8. I just press enter and I get this negative 0.661. So there's my slope. To write my tangent line, we can go y minus 4 equals negative 0.661, and that's going to give me x minus 7. And there's our tangent line. Now, so pretty easy to do right there. So for part C, now we're looking for the speed of the vector. Now we should remember from yesterday, we want the actual speed. But remember, they give me the component speed. They give me x prime of t, the horizontal component for this velocity, and they give me the y component for the velocity, or y prime of t. We're looking for the speed. That's this magnitude right there. That's the magnitude of our velocity. And we should hopefully remember from yesterday, to get the speed, which is the magnitude of our velocity, is nothing more than just the Pythagorean theorem. X prime of t squared plus y prime of t squared. And I can just plug in my numbers. Now I already have the derivative. dx dt is sine of t squared. I want to square that, and I'm going to plug in my 2. So this becomes sine of 8 squared plus the cosine y prime of t, I have it right here, of 4 squared. And I just typed that in my calculator right here. So let's go ahead and do that. When I type this in, square root, I'm going to go with the sine, you don't need the parentheses, of 4, just go to the, oops, sorry, this should be of 8, excuse me, of 8 squared plus, let me turn on my light here, so no, that didn't help much. So, alright, so I actually kind of made it a little darker. Alright, so plus, now I'm going to do the cosine of 4 squared. And I just press enter, and we get 1.186. Now remember, this is the actual speed of the particle itself. Now if I wanted to get the distance traveled, right, we would set up as an integral of x prime of t squared plus y prime of t squared dt from a to b. That's if I wanted to get distance, because remember distance is the antiderivative of our velocity, but we don't have to do that for this one because we're not asked that. Now for part D, okay, so far it's been pretty easy. For part D though, they wanted me to get the actual position of the particle. Well, we're given velocity, therefore we need antiderivatives. We're going to need the antiderivative of velocity at t equals 1. Now, let's write down what we do know. We know x prime of t, and we know y prime of t. And we also know that at t equals 2, our position is 7, 4. So when I want to find the position at t equals 1, I'm going to use the antiderivative. But you got to be careful. We actually have to set up two separate integrals. So the first one I'm going to find is the x position. To get the x position, we're going to take the antiderivative of x prime of t dt. Now, we are going to use the fundamental theorem here, because I know I'm looking for 1, but I know 2. So I'm going to integrate this from 1 to 2. Remember, this is going to give me my change in x values. Let me write that down. This is big for us. That's our change in the x values right there. And if I integrate that by using the FTC, we get where x is at 2 minus the position of x, of x at 1. This is our FTC problem right here. Now I'm going to set this up. I'm going to plug it in from 1 to 2. We know x prime of t is sine of t cubed dt. And I know x of 2, which we're told at 2, my x value is 7 minus x of 1, what I'm looking for. So I'm just going to type that in my calculator here. There it is. Go to Menu, Calculus, Numerical Integral. I want to find the change of x from 1 to 2. And I'm just going to type this in. Sine of t cubed. T to the third dt. Now I could use x if I wanted to, x and x. I get the same answer, but because we're dealing with parametrics and vectors, I like to keep in terms of t. I press enter, I get 0.218. So between 1 and 2 seconds or whatever, the particle moved 0.218 units. So if I'm ending at 7, where do we start at? So we just solve for x of 1. And I'm going to go and do that real quickly. I minus 7 for my answer. Whoops, delete. And I change the sign because of the negative x1, and we get 6.782. There's our x coordinate. Now, to get the y coordinate, we do the same thing. Y of 1 from 1 to 2, but this time we use y prime of t dt. That's going to equal y of 2 minus y of 1. And again, if I just use my calculator, now I do know the antiderivative, the derivative of y prime. It is up here. There it is, cosine of t squared. That goes here. Cosine t squared dt. My y value at 2, I know is 4 minus my y value at 1, which is what I'm looking for. And I'm just going to type this in my calculator just like I did before. And then you got to complain how long this takes. I used to have to do this by hand. Now you may be thinking, hey, can't I just use substitution? You can try it, but you're going to realize it fails. We're not ready to integrate this one yet. To integrate something like cosine t squared, you really can't. It has no antiderivative. We can approximate it using what we call a series or sequence. There's my cosine t squared. dt, we're going to use, when we get the Taylor series, we'll talk all about those, how to solve something like this by hand. We press enter, and I get this negative 0.443 equals 4 minus y of 1. This one's not that hard to solve. I'm going to subtract 4, that's going to give me negative 4.443, but I changed my sign because of the negative, so I get positive 4.443. And there's our y value. Whoops. And let me go and turn on my light here again. There we go. So we're going to write our answer as a vector. So to get our position vector, use your chevrons because we're talking about a vector. 6.782, 4.443. And there's your position vector. Alright, so how would the AP grade this? I want to show you guys this. You can stop right now if you want to, but I want to show you real quickly how the AP would grade this problem. This is an AP question. Now, for part A, just getting the acceleration, plus 1. Getting the point, plus 1. Now, for part B, getting the derivative, plus 1. Getting your tangent line, plus 1. That's not going to be worth much. So far we got 4 points right here. And to get the speed vector, it's just a plug and chug into a formula. You don't need all this stuff. This is all you really need to answer the question. So it's not worth much, only plus 1. Now I have a theory. On any AP free response, you can get 5 points in 5 minutes. When we got those 3 pretty quickly, so probably less than 5 minutes. Down here it takes a little bit longer. You're going to solve each one of these independently from each other. So what's going to happen is you're going to get plus 1 for your equation, for your integral. Same thing down here, plus 1 for your integral. And you get plus 1s for your answer. Right there. So that's worth about 4 points down here. And they don't take too long to do. This is an easy 9 points for us on the AP exam. So I hope you guys enjoyed the lesson. Now if you go to part B, I'll show you how to use parametrics. On part 2, we'll show you how to do parametrics on the calculator with the graphing, how we can utilize the graph on it if you want to. Okay? See you there. Bye-bye.